2.2.9 Zero Downtime Deployment, the Mental Model and the Benefit. For many teams, deployment used to mean one thing. Someone announces a maintenance window, the system goes offline, files are copied, servers restart, and everyone waits, hoping everything comes back. Users see outages, engineers hold their breath. And if something goes wrong, the only plan is bring it back up and fast when whatever it takes. Zero downtime deployment was invented to remove that fear. It doesn't try to make risky releases less scary. It tries to remove the risk from the release itself, and the idea behind it is actually simple. Instead of stopping the old version, so the new one can start, both versions run side by side, while traffic is gently guided from one to the other. No drama, no blackout moment, just a gradual handoff. That shift in thinking is everything, and the real breakthrough happens when we stop thinking in terms of off and on, and instead let both worlds exist for a moment, side by side. When a new version is ready, the pipeline doesn't immediately replace anything. The old version keeps running. The new version starts quietly beside it. A load balancer sits in the middle and decides who gets traffic. At first, it sends all users to the old version. Then, slowly, carefully, it starts sending some requests to the new one. If the new version behaves well, more traffic flows to it. If anything feels wrong, traffic simply flows back to the old version. No outage, no panic, just a calm decision. And that brings us to a subtle but important detail. But once both versions are alive, the next question becomes much more human. What happens to real people who are right in the middle of something? In old release processes, servers were often restarted immediately. Users submitting forms lost everything. Payments failed halfway. Sessions disappeared mid-action. Zero downtime deployment does something kinder. When a server needs to shut down, the load balancer stops sending it new requests, but it lets the existing requests finish. We call that connection draining. It means ongoing uploads. Finished, transactions complete. People don't lose work. The system slows down gracefully instead of slamming the door. As traffic begins to shift, something important quietly happens in the background. The system starts watching itself. As traffic moves, the pipeline keeps asking questions. Is the new version responding? Is latency stable? Are error rates rising? Every instance has health checks. If an instance misbehaves, the load balancer simply stops sending it traffic. Failures become small and local, not global events. And crucially, teams learn to trust something powerful. The system can detect bad conditions before users feel them. Of course, the moment things get serious is when databases enter the picture, because that's where zero downtime requires a bit of choreography. Zero downtime gets tricky when databases change. If the new version expects a new column, but the old version doesn't know it exists, suddenly both versions cannot live together. That's why experienced teams make database changes in two phases. First, they make the database compatible with both versions. They add fields, not remove them. They write migrations that don't break old behavior. Only later, when every system is using the new code, they slowly clean up what is no longer needed. It's a slow dance, but it prevents catastrophe. And once teams understand that dance, schema changes stop feeling scary. And sometimes, before we trust a new version with real decisions, we give it something like a dress rehearsal. Sometimes teams want the new version to experience real load, without letting it make real decisions yet. So they mirror traffic. Users still talk to the old version, but a copy of the same requests is silently sent to the new one. The new version processes everything, logs insights, and reveals weaknesses, while its responses are ignored. It's like training a pilot. The student flies the same plane, but the instructor still controls the landing. By the time the new version becomes active, it has already lived through reality once. And here's the part teams eventually fall in love with. Mistakes no longer feel like emergencies. In traditional deployments, rollback feels like a rescue mission. People rush, scripts run fast, everyone wonders what else might break. With zero downtime strategies, rollback is simply a decision. Blue-green flips traffic back instantly. Rolling updates stop increasing rollout and gently step backward. Canary pauses, observes, and reverses the small group that saw issues. The goal is not never fail. The goal is fail in ways that don't hurt anyone. None of this works on intuition alone. It works because rollout and observation move together. Zero downtime doesn't trust luck. It watches error spikes, latency changes, unexpected drops in traffic, odd user behaviors. If something feels wrong, the pipeline can automatically halt the rollout or shift traffic back. Humans still decide the final course. But the machines notice patterns faster than people ever could. From the outside, zero downtime may look like a purely technical trick, but its biggest consequences live far beyond engineering. Zero downtime deployment sounds technical, but its biggest benefits aren't technical at all. Users stop experiencing interruptions. Revenue doesn't freeze during releases. Teams release more often. With less stress. Incidents drop, not because code is perfect, but because the rollout is controlled. Releases stop feeling like events. They start feeling like routines. And routine is exactly what safety looks like. And if you ever have to explain this in an interview, the clearest version sounds surprisingly simple. If an interviewer asks, "What does zero downtime deployment actually change?" A strong answer sounds like this. It removes the outage moment. The old version keeps serving users while the new one comes online. Traffic shifts gradually, health is monitored continuously, database changes are made backward, compatible, and rollback becomes safe instead of dramatic. Not buzzwords, just understanding. In this entire section, we learned that modern software delivery isn't about pushing buttons. It's about building a system that moves change safely, predictably, and repeatedly. We saw how continuous integration makes every commit testable. We separated continuous delivery from continuous deployment, not by tools, but by one simple question: who decides when to release? We walked through pipelines step by step and saw how stages, quality gates, and validation turn uncertainty into discipline. We learned why Docker images matter, because they give us reproducible artifacts instead of fragile works on my laptop setups. We layered on automated testing, unit integration, and regression, so decisions aren't based on hope, but on evidence. We treated infrastructure and configuration as code, so environments finally behave like software, not like fragile machines. And then we explored deployment strategies, rolling, blue-green, canary, and ended with a powerful idea. Deployments don't have to hurt. With the right design, they simply become quiet routines. That is the real promise of CI/CD, small changes, shipped often, with confidence instead of fear. And now, where we go next? Because once software can move safely, a new challenge appears. How do we keep systems healthy while they run? In the next section, we shift from shipping code to operating systems in the real world, at scale, under load, and under pressure. We'll talk about observability, reliability, scaling, failure, backups, and what it really means to design systems that stay available when things inevitably go wrong. Welcome to Section 3, System Operability. End of 2.2.9.